At the end of this video, you should be able to define chemistry and list examples of the branches of chemistry. Chapter 1, Section 1, Chemistry is a Physical Science. The natural sciences were once divided into two broad categories, the biological sciences and the physical sciences. Living things are the main focus of the biological sciences. The physical sciences focus mainly on non-living things. However, because we now know that both living and non-living matter have a chemical structure, chemistry is central to all the sciences, and there are no longer distinct divisions between the biological and physical sciences. Chemistry is the study of the composition, structure, and properties of matter and the changes it undergoes. Chemistry deals with questions such as, what is that material made of? What is its makeup and internal arrangement? How does it behave and change when heated, cooled, or mixed with other materials, and why does this behavior occur? Chemists answer these kinds of questions in their daily work. Instruments are routinely used in chemistry to extend our ability to observe and make measurements. Instruments make it possible, for example, to look at microstructures, things that are too tiny to be seen with the unaided eye. The scanning electron microscope reveals tiny structures by beaming particles called electrons at materials. When the electrons hit a material, they scatter and produce a pattern that shows the material's microstructure. Invisible rays called X-rays can also be used to look at microstructures. The patterns that appear, called X-ray diffraction patterns, can be analyzed to reveal the arrangements of atoms, molecules, or other particles that make up the material. By learning about microstructures, chemists can explain the behavior of macrostructures, the visible things all around you. Branches of chemistry. Chemistry includes many different branches of study and research. The following are 6 main areas or branches of study. But like the biological and physical sciences, these branches often overlap. 1. Organic chemistry, the study of most carbon-containing compounds. 2. Inorganic chemistry, the study of all substances not classified as organic, mainly those compounds that do not contain carbon. 3. Physical chemistry, the study of the properties and changes of matter and their relation to energy. 4. Analytical chemistry, the identification of the components and composition of materials. 5. Biochemistry, the study of substances and processes occurring in living things. 6. Theoretical chemistry, the use of mathematics and computers to understand the principles behind observed chemical behavior and to design and predict the properties of new compounds.
Chemistry is the study of how matter changes or can be changed and what effects are produced. Organic chemistry is the study of most carbon-containing compounds. Biochemistry specifically studies those organic compounds found in living organisms, the processes they undergo, and the interaction of living organisms with inorganic compounds. Inorganic chemistry studies all substances not classified as organic, mainly those compounds that do not contain carbon. Another way to look at chemistry is to consider the chemical reactions being studied. Physical chemistry studies the properties and changes of matter and their relation to energy. It can involve both organic and inorganic compounds. Analytical chemistry focuses on identifying a material's components and composition. Theoretical chemistry uses mathematics and computers to understand the principles behind observed chemical behavior in order to design new compounds and predict their properties.
In all areas of chemistry, scientists work with chemicals. A chemical is any substance that has a definite composition. For example, consider the material called sucrose or cane sugar. It has a definite composition in terms of the atoms that compose it. It is produced by certain plants in a chemical process called photosynthesis. Sucrose is a chemical. Carbon dioxide, water, and countless other substances are chemicals as well. Knowing the properties of chemicals allows chemists to find suitable uses for them. For example, researchers have synthesized new substances such as artificial sweeteners and synthetic fibers. The reactions used to make these chemicals are carried out on a large scale to make new products such as sweeteners and fabrics available for consumers. At this point, you should be able to define chemistry and list examples of the branches of chemistry.